Hello. Now, in the 9.0 release of Visual COBOL and Enterprise Developer, we introduced a number of new features into the COBOL language. And in this video, the compiler engineers who implemented those features are going to walk you through the changes themselves and show you a few quick demos. Now, at the end, I'll tell you how you can get further details on this release, including details on a new COBOL training course, which is free to access. Let's kick things off first of all with two major new enhancements to the COBOL language: local fields and parameterized sections. Now, both of these are designed to make life easier for the COBOL developer who is maintaining large COBOL applications, but equally to help make life easier when it comes to onboarding new recruits by giving them access to semantics and concepts within the COBOL language that they're already familiar with. Let's hand it over to Erin to tell you more.
Hi, I'll be talking about parameterized sections and local variables. These are major language innovations, so I'll briefly motivate and explain these before showing a quick demo. Control flow in a COBOL program is typically done by performing sections. Prior to 9.0, sections couldn't take parameters. Sections were only able to operate on variables which were being shared with the rest of the program, and this creates a risk of overwriting or corrupting variables which are being used elsewhere, especially in larger programs. Programmers can try to avoid this by creating lots of temporary variables, but this still isn't a great solution because you end up with code that is difficult to read and error-prone. These new features aim to address that problem. Let's take a look. Firstly, local variables. You can now declare local variables in a section using the declare keyword. And each section has its own local scoping, so only that section perform is able to access its local variables. When a section performs a different section, or even itself, its variables are preserved for later, for once that other section finishes. To summarize local variables, we can say that declared variables are instance local. We also have parameterized sections. So you can now give a section some parameters, and this enforces that any code performing that section must supply data of matching types. A section can also have an explicit return type, and this dictates what gets returned up to the scope of the code that performed that section. Bringing these two features together, this enables programmers to write code which mitigates the risks associated with the use of global temporary variables, such as accidental overwrites. One interesting thing this allows us to do is to safely recurse a section. From a programmer's perspective, this allows us to write code which is more readable, easy to maintain, with fewer bugs arising from changes. It also helps to bring Visual COBOL into line with other modern languages. Crucially, this helps new developers learn COBOL, as it's more familiar to those coming from other languages. I'll now run through a quick demo program of Fibonacci, which uses these new features. The section fib does the computation, and the first thing you'll notice is probably that it looks quite different to sections you might be used to. It takes a parameter n, and this means that performing code must supply a binary long, or else we'll get a compiler error. It also returns fibn, also binary long, and both n and fibn become local variables inside the section. If we now look inside the section, skipping over the base case at n greater than 1, we're declaring another two local variables using the declare keyword. We're then making recursive calls that go back into fib with slightly smaller values of n. We're taking the return values from those and storing them in our local variables. This demonstrates instance local scoping, so where each perform of fib gets its own set of local variables. Otherwise, variables would get overwritten, which in this case, wouldn't be very useful. Finally, we return the sum of the two. Running this program, this gives the correct answer of 55. That's everything I have to show. Thanks for listening.
Now, integrating COBOL with Java is a common approach in modernizing many legacy systems, but it's not always straightforward for the developer. But these new interop features available in 9.0 are designed to make that process simple, pain-free, and quick to implement. Here's Steve to tell you more about it.
So IBM introduced this feature into Enterprise COBOL 6.4. It removes the need for domain-specific knowledge around JNI and COBOL, just making it easier for developers less familiar with COBOL or Java to create COBOL applications which work for both. And IBM most likely developed this feature to slow down migration of COBOL to other languages and help new Java applications interact with legacy COBOL. There's 4 parts to this feature. There's Java-compatible COBOL data items. COBOL programs can call Java static methods. Java programs can call COBOL programs, and you can share COBOL working storage items with Java programs. And all these features can be used in the same application. So the first one is Java-compatible data items. IBM have defined a set of Java-compatible COBOL data items for use when interacting with Java. For example, pick 9, comp, and 5 and comp can map to short, long, and ints. Pick 9, N9, comp 3, and display will map to Java big decimal. Pick X, U, and N map to Java strings. Array types are also supported. When the item isn't supported natively in Java, automatic conversion under the covers happens. And there's a full table in the documentation of all the types, and there's a few I haven't mentioned. So COBOL programs calling Java static methods. This is done with the call statement using a Java prefix. So Java, package name, class name, static method, using a series of COBOL compatible data items, returning as well. So a quick example. So we have an array of colors, and we can call class number 1 a little sort method using colors, and then display the results afterwards. Quick snippet is static method with an array of strings, just using Java sort method, and so Java can access and manipulate the COBOL data items. So yeah, using returning, and you just need to be aware of a few things like mutable data types. It's all in the documentation. So Java calling COBOL programs. This is done using the progs class, which is generated by the COBOL compiler under the covers based on the procedure division using. The COBOL program is compiled with the Java COBOL directive and the Java package name directive. So introduce this new directive called Java callable. We have a simple, typical code procedure using in COBOL. A number, some strings, and pick 9v99. So typical COBOL program would then use this prog class and then invoke a method called program1, passing all the Java data types, strings, int, big decimal, and under the covers, any appropriate conversion gets done. Quickly moving on, sharing of COBOL working storage items with Java programs. COBOL items in working storage are marked with a new directive called Java shareable. For example, this means all these data items can now be shared with Java. And then under the covers, the COBOL compiler will generate an strg class, which stands for storage, to allow access with get and put methods. So typically to access author, you have program1, books, author, get, so using array syntax. And you can do the same with puts. You can change the arrays, update the COBOL working storage with the put methods. So that's a very rapid introduction to the syntax. I'm just going to go for a very quick demo in Eclipse There's a new project system, which the Eclipse team have implemented, and Raymond will talk about that. So here we have, we're going to call COBOL calling. So Java's ready to call our COBOL program, so I'm just going to hit F8. Here we are into COBOL, and we can display the data items. Where's my console gone? Not sure what's happened there. Oh, yeah, I haven't done any displays yet, so I'm just in the moves, apologise. So we've updated, we've called the COBOL program, we've updated some working storage items, passed through the provision using. Let's just jump back to the Java program. Right, so here we're going to use some gets to get hold of the working storage. And we can display these out on the screen. And then again, we can update the working storage using some puts. And then we can then display the updated content. And then lastly, we're going to call a static method from COBOL, passing it an array of colors. And then we're going to sort them. And then COBOL program will display the new colors. Oops. Oh, well, seem to have pressed on key there, but so yeah, it would have displayed all the colors sorted in order, and that's just a very rapid demo of the new syntax. And thank you very much.
Now, date time handling is, of course, common in COBOL applications, but it can get quite complex. Here's Alex to give you an update on several new intrinsic functions we've introduced into the language that could help simplify this area of your applications and that you can rely on for consistent behavior across different platforms you deploy to.
Hi, I'm Alex. I'll be showing you some of the new date and time intrinsic functions. These are baked into the language, ready to use. So in this first example on screen, we use the formatted current date function to get the current date in a format of our choice. There are many formats to choose from. We can see 3 examples here and their corresponding outputs. So the third one here requests a week date and then a local time with an offset from UTC. Here in the UK, that's +1 hour at the moment. Right, next, let's do some error checking using the test formatted datetime function. This is useful when getting a direct input from the user or reading values from a database. We want to make sure that the datetime string is valid and that it conforms to the format that we specify. So just look at an example of that. Here is our format. Here is our input. Oh no, although the format is valid, there aren't 29 days in February in the year 2021, and the function will return the location of the error. Here it's character offset 10. What we meant to say was 2020 success. Right, so that's checked. And finally, in this next example, we take the datetime string we just checked and convert it to an easily storable numeric form. Many computer systems store their time information relative to the 1st of January 1601. And this first function here, integer formatted date, extracts the date part of our input and returns the number of days since that starting point in 1601. And for the time, this function here will return the number of seconds past midnight. So all in all, here are our numeric forms. This is for the date, this is for the time, and there's even a function which combines the two into a single fixed or floating point value. In summary, we got an input from the user, checked that it was valid, then converted it to an easy to store numeric form. Thank you.
Now, traditionally, COBOL developers have had to declare the size of a field at compile time. But in this segment, Dara is going to tell you about some new features for dynamic length items.
Hello, I'm Dara. I'm going to give you a little taste of how the new COBOL dynamic length clause works. Dynamic length items must either be a picx or the new UFT data type PQ. When used as a target, memory is automatically allocated, and a current length is set based on the source. Here we have the source hello being moved into the dynamic item dyne1, and if we query the size of dyne1, it should be the size of hello, which is 5. And you can see over here, it's 5. When dynamic length is the source or reference modified, it is a normal fixed length item of its current length, which allows us to do operations such as display. Dynamic length can be used in intrinsic functions. For example, the uppercase function here, we should get a capital hello. There we go. The length of the dynamic length item can be explicitly set. We are now setting the dynamic item dyne1 to 4, which should truncate the letter O, giving us hell. There we go. It's important to note that not all statements are supported. Here are the supported ones, including the if statement and the display statement. Introduced in previous releases is the allocate statement, which also helps with dynamic memory requirements. In the simplest form, it works by passing the desired memory size in characters, and a pointer to the allocated memory is returned. Thank you for listening.
Now, next up, we've got some new syntax that helps make addressing fields within groups much more intuitive, especially if you're new to COBOL. Here's Zach to tell you how.
So we've added a new way to access members of group item. So here we've got a table of phrases, and previously we'd have to access them like this. So we've got display French of greetings of phrases. And now using : we can access them like this. So phrases : greetings : French. So this is just kind of a different way of doing things. It's just an alternative, but it perhaps might be a bit more intuitive for some, maybe a bit more familiar for people coming from languages like Java. But : syntax does more than just that. It can also be used for dereferencing typed pointers. This is quite powerful and pairs pretty well with local variables. So in this case, we have these data items, London of type city, which is a type declared up here, and Big Ben of type place, which is a type declared up here. We can store pointers to these in the data items current city and current place. So go ahead and do that. And using that pointer, we can access the elements of the underlying data item, London and Big Ben, using : So we can add the current place as one of the must visit places in the current city. We can add the name and the latitude and the longitude to the current place using : and we can display the name of the third must visit place in the current city, and there we're using : to dereference the current city pointer, getting the resultant pointer of type place and dereferencing that to get the name. And all the while we've been using the original London and Big Ben items underneath. Again, the aim here is that this is perhaps a more intuitive way of using pointers for those coming from other languages. And that's :
Okay, last up, new 64-bit support for mainframe pointers. Here's Vadim to tell you more.
This presentation describes the MOD64 directive and supporting language features introduced in the 8.0 release. Visual COBOL allows the contents of pointer items to be stored in a format that is compatible with that used on an IBM mainframe. The use of mainframe-style pointers is controlled with the mode compiler directive. There is a choice between NOA mode, 24-bit, 31-bit, and now 64-bit pointers, depending on the dialect in use. Programs compiled with the NOA mode directive, which is the default, use PC-style pointers and are known as NONA mode compiled programs. The MOD64 directive was introduced in the 8.0 release. It requires two other directives, P64 and dialect and COBOL. When MOD64 is set, pointer items occupy 8 bytes, and therefore MOD64 programs have access to the full 64-bit address space as any other P64 program. All the usual pointer operations work as expected. Allocate allocates above bar, above 2 GB by default in MOD64. The main effect of MOD64 is the ability to allocate practically unlimited amounts of memory via allocate, limited only by the amount of available virtual memory, as compared to MOD31 programs. So let's look at a very quick demo. This program declares a pointer item, sets it to an address of another item, and you can see that the length of this pointer is indeed 8 bytes, all bits are used, all the usual pointer operations work as expected, and we can indeed allocate a lot of memory. So in this program we will allocate 5 GB of RAM. And now, when we look at Task Manager, we can indeed see that our program has allocated 5 GB of RAM. And a MOD31 program would have crashed by now, not a MOD64. The second part of this presentation talks about mixed mode applications. Now, imagine if you have a large MOD31 application consisting of multiple programs. It would be difficult and risky to convert it in one go to a MOD64. To support a gradual incremental migration, one program at a time, there are several new language features. One is pointer 32. It's a 32-bit MOD31 compatible pointer type. You can use it to pass pointers as parameters between a MOD64 and a MOD31 programs. It can be allocated with the allocate statement when using the log31 clause, or assigned from a usage pointer item. But there could be a data truncation when assigning a 64-bit pointer to a 32-bit pointer 32. Obviously, this happens just like if there would be data truncation if you were assigning a 64-bit integer to a 32-bit integer. To avoid this data truncation, you can use the new data31 directive. This directive ensures that the data division of the MOD64 program is placed below bar, thus making the address space of the MOD64 program compatible with MOD31 programs, and eliminating the possibility of data truncation when assigning 64-bit pointer data items to 32-bit pointer 32s. Additionally, the data31 directive allows passing of parameters by reference between a MOD31 and the MOD64 programs. So in the second demo, we have an MOD64 program that has P64 and dialect and COBOL set and data31. This P64 program will call an MOD31 program. We will pass a parameter, a text string containing MOD64 data by reference, and we will pass a pointer 32 by value, and it points to a number. In the MOD31 program, we will modify the values referred to by these parameters. So when we come back, we can check that the modifications were successful. And in a MOD31 program, there's nothing suspicious here. We have MOD31 and P64. We set the address of a Nicker storage item to the pointer 32. We change its value. We take our parameter passed by reference. We change the string to MOD31 data. And then when we come back, we can see that the values have been changed as we expect. So we have seamless interoperability between Node 64 and the Node 31 programs. It works the same way in native COBOL and in managed COBOL, basically allowing you to call Node 31 programs from Node 64 programs and vice versa, and thus allowing you to gradually migrate large Node 31 programs to Node 64. This concludes the presentation. Thank you.
Now, I hope you spotted something in this release that will help you improve your COBOL coding experience in the future. Thanks to all of our engineers for the great work and, of course, the demos they provided today. Now, you can find out more details about the new syntax and other features in the online documentation, including for past releases as well, all in one convenient location. And if you'd like to hear more about the release overview, including market news, as well as other new capabilities in the 9.0 release, head over to the BrightTalk platform and drop in on our 9.0 launch webinar recording. And finally, we've created a brand new COBOL training course, which is freely available, including access to the development tools. And it's the perfect starting point for new COBOL developers or other language developers looking to quickly get an understanding of COBOL. Head over to COBOL.com to find out more. Thanks for listening.